typing on a regular physical keyboard, one thing that we do every day, extensively on one day, less on the other. And I'm Anna from Aalto University, and I did this work with my colleagues Daryl, Weir, and Antti, Oulasvirta. And so I hope that I can surprise you a little bit with this talk, because we had some very interesting findings studying everyday typists, people in this room, people outside of this room, that use their keyboard every day. And we wanted to know, how do they actually type, because we know surprisingly little about this. And I want to start with you thinking about how do you type and what do you know about how you type. So I want to ask a couple of questions. Who of you thinks that you can type fast? Yeah, not everybody. Who has taken a typing course at some point in his life? Surprisingly many. And who uses more than 6 fingers for typing? Close to all the room. A little bit more difficult question, the last one. Who uses the right thumb to press the spacebar, similar to the guy here in the picture? You answered quite quickly. You're well aware of how you type. So to introduce you to the system, if you type something like that, then chances are that you have taken a touch typing course at some point in your life. And the touch typing is something that has been around for more than 100 years. This picture is from 1959. It's from one of the main typewriter producers, and it shows you the finger-to-key mapping of the touch typing system, which finger is supposed to press which key. And this is a very strict mapping with this system, for those of you who haven't learned it or don't know about it. As part of the touch typing system, you are taught to use this fixed finger-to-key mapping, so you're not allowed to vary from this. But you are also taught that you should always look at the screen and not at your fingers. Some are trained really harsh in that by covering the fingers and all of these things. And you are taught to keep your hands static at the so-called home row of the keyboard, which is the middle row. You should put your fingers on the F and J key, where there are the little nibbles on the keyboard for those that never saw it. So those are the principles of the touch typing system. And we know this system pretty well. As I said, it's been around for like more than 100 years, and also research knows quite well about it. But what if you don't do the touch typing system? But what if you do something like this? Maybe move your hands around much more than those touch typists were trained to do, or that you only use one finger of the hand, like the guy there on the left, put the other to some weird angle. Does that matter somehow to your speed, or are you therefore a bad typist? Are you slow, or does that mean you will get some repetitive strain injury or something like that? The thing is, we actually don't know. Nobody has taken this time to study non-touch typists, which are, in my experience, many people. I never learned the touch typing system in school, and I think, depending on the country, it's not even taught. Here's a little bit about what we do know about typists, and this research mainly comes from the 1920s to 1980s, and it has been done with professional employed typists that have been taught for years in how to type. At that time, it was mainly done on typewriters or on some modern computer keyboards of that era. We know from that era, we know that average speed was about 75 words per minute, and they had them type random letters as well, and found that it was like half as fast. And they found this actually already in the 1930s. Daryl did these studies that he used to find a better keyboard layout, if you know about the Daryl simplified keyboard. For example, he tried to use hand alternation, that frequent letter pairs would be typed by different hands, because he found that that was faster on the typewriter. And many of the models and theories that try to explain the cognitive and motoric processes behind typing, from when you first see a text to executing the finger movements to enter the letters, they are actually based on all these findings that have been made on the typewriters with the secretaries. Even the modern models that try to capture this, there's one from 2008, for example, that tries to explain a list of typing behavior and typing phenomena, all based on these studies from the 70s or 80s. But typing on a typewriter is very different from typing on a modern computer keyboard. I don't know how many of you have had the experience on typing on a typewriter, but I just bought one and it's so different. It's really hard to hit the keys. You have to make these huge movements. But also the tasks that we do now are very different. So back then they mainly typed, things for the bosses. They typed letters and conversations or proposals or maybe a table or something. But now we use our keyboards for all kinds of things. We chat, we write quick emails, we program, we use Photoshop, so even things unrelated to typing actual language. So we did a study of everyday typing on a regular computer keyboard and with everyday typists. And we wanted to capture the complex motor movements of the fingers. So typing is something that happens unconsciously and very fast. So maybe some of you had troubles answering the question about which finger you use for the spacebar, because we don't really think about how we type. So I couldn't just ask you, what typing strategy do you use, because you couldn't tell me that. It happens very, very fast. So we decided to use a motion capture system, and this is the first study that uses a motion capture system for capturing how we type. But with that, we can capture every thing, like the fingers and the hands, how they move at and between each key press. So very detailed information that we get there. And it allows us to exactly identify which finger presses which key and extend the regular typing log that we capture in text entry experiments of the key presses and the timing of key presses. We can now extend that with the information which finger pressed that key. And we also used eye tracking classes to find out where people look while they are typing. And then we also had this reference video of the hands that we captured. We did the study with 30 typists. 17 of them were female. And we really wanted to recruit kind of everybody. So we tried to go a little bit out the university, but you know how hard it is to get participants. But we wanted to cover a broad age group, and particularly a broad performance group. So we had people ranging from age from 20 to 55, which is not that old, but still okay, and ranging from performance from 34 to 79 words per minute. And we allowed participants to choose between two different languages, trying to capture their best movement strategies that they usually perform. So we're at a Finnish university, so these common languages were usually either Finnish or English. So we set up the experiment with these two languages. We used the Finnish keyboard and made sure that they are all familiar with that. It's very similar to the normal English, but extended with a couple of special letters. But I want to note already now that for all the results that I'm presenting, we couldn't find any difference between those two languages, although they are very, very different. And where we needed, we also abstracted from statistical differences between these languages. And the interesting point, so here we looked at the two different groups of typists. So we asked in the beginning, or at the end through a survey, have you ever taken a touch typing course and showed a little figure? Do you know, like the finger to key mapping that I showed you before, do you know what this is? Do you use that? And 13 of them answered yes. I have taken the touch typing course at some point, and I'm using the system, and 17 have said no, I have never seen this. This is the task that we gave them to do. We had 3 conditions. We gave them regular sentences, either in Finnish or English, to transcribe. We had a random condition where we had a short sequence of 6 letters randomly put together. And then we had a mixed condition where we inserted this random letter sequence in the regular sentence and had them type 50 of each of them. yeah, and they were, maybe I should mention that, they were allowed to read through the sentence and then type it out as they feel comfortable to do, as they would usually type. Yeah, so the data that results from that is the how we type dataset. It has the motion capture data of 52 markers recorded at 240 frames per second. It has the key press data extended with which finger pressed which key, and the eye tracking data showing where the person looked during typing, and then the reference video. And this dataset is published, so it's the first really extensive dataset with all these kinds of information for modern keyboard users. And you can do with it whatever you want. But here's what we did with it. So we did a couple of different analyses, and they are in the paper, especially for comparing these two groups that I just showed to you, these trained typists and the untrained typists. But I just want to highlight a couple of them. The most surprising thing was that we found no difference in the performance of the two groups, the errors, or the uncorrected errors that they made, and their efficiency. So we couldn't find that touch typists were faster than those untrained typists, which is surprising. So we asked the question, what makes a typist fast then, if it's not the touch typing system? And we found 3 factors related to this motor behavior that we could now analyze because of the motion capture data, and I'm now going to through them in more detail. And we also looked at the visual attention, so at where they looked. And we found that the first thing, fast typists use their finger very consistently. So we looked at the average entropy of which finger presses which key, so how much surprise is in what finger presses which key, and averaged over that over the keys. So people that always use the same finger for typing, for hitting a certain key, were faster than people that varied this finger to key mapping, and that is shown on this graph, where on the y-axis we have the interkey interval, so the time between 2 key presses, the shorter the better, and on the x-axis we have this entropy. And yeah, so we found this correlation between the entropy and the performance. The second thing, fast typists prepare upcoming key presses. So we looked at the average distance of a finger to its key that it's going to press next, already at the preceding key press. So one finger presses a key, and then another finger already moves towards the next key that is supposed to be typed next. And this, intuitively, it makes sense, right? So this is, you're closer to the key, and therefore you are faster at typing. So again, we found this correlation for each of the two groups, for the trained typists and the untrained typists, between the amount of preparation that they do and the performance. The third thing, fast typists do not move their hands, or at least less as the slower typists do. So we looked at the markers at the back of the hand and looked at how much the hand globally moves. So either you could move your whole hand towards a key, or you could stretch out your fingers individually. And we found that the more you move your whole hand, the slower you are usually. Interestingly, we found this very sharp difference between the left and the right hand, in that the left hand moves for nearly everybody. It's right static there, whereas the right hand moves quite a lot over the keyboard. And finally, fast typists do not look at their hands. This is what is taught in the touch typing system, and it seems to make sense. So the percentage of time looking at the fingers is an indicator for how fast somebody can type. But we also see here on the very left that there are a couple of non-touch typists that can also type without looking at their fingers, and they are very fast with that. So as a summary, we found that independent if they are touch typists or not, there are these 4 factors that make you fast at typing, independent of this strategy that you use. It's that you have this fixed finger to key mapping, that you keep looking at the screen and not at your fingers, that you keep your hands static, and that you prepare the key presses. But we don't know yet about this finger-to-key mapping, how many fingers people use and what finger they use to press which key. So we found that fast typists actually can use any number of fingers. On average, touch typists used about 8.5 fingers, versus the untrained typists used just 6 fingers. But there was no correlation between performance and the number of fingers. So there were very fast typists using all 10 fingers, but also very slow ones. And this is really surprising. But we wanted also to know more specifically which fingers were used to press which key. So we looked at these finger-to-key mappings of the people typing. So which finger do they use to press which key, identified with the motion capture data. And then we used hierarchical clustering to group the ones together that had these similar mappings. And we find 4 strategies for the left hand and 6 for the right hand. And they ranged from anything between just using 1 or 2 fingers per hand to a modified version of the touch typing system, or using the full 4 or 5 fingers of the hand, as the touch typing system would tell you to do. And more about these clusters you can also find in the paper. They're very interesting. Maybe you'll find yourself in there. So now we have the overview of what touch typists do and also what untrained typists do. And more specifically, we know what fast typists do, and that's the interesting thing. And what is really worth highlighting again is that all of these factors have emerged for the fast typists, even if they never took a typing course, if they were not instructed or were not covered their hands. They kept their eyes on the screen, and they kept their fingers more static, and they tried to prepare the key presses just by using the keyboard and doing all kinds of tasks with it, and without any deliberate practice. If you want to get to 80 words per minute with the touch typing system, you really have to invest hundreds of hours of training where you sit there and do boring exercises. But we found that even if you never did that, you may have come to that point at some point if you use your keyboard every day. So we have published this dataset, as I said, and we want to motivate you to also use this methodology of using the motion capture system to discover these subtle but very important movements of your hands and fingers around any kinds of manual input, also with the smartphone or tablet or whatever. This is really, really important as a basis for how we interact with these devices. And we should look more about this full movement strategies around these devices. So more information can be found on our project page. And if you want the dataset, I'm happy to provide it. Thanks.
Google. It's really great work, as you say. Typing is such a basic skill in modern life, and everybody assumes that's being heavily studied, but actual solid studies are so rare, to the extent that there are major economic theories built on the fact that either QWERTY or Dvorak is better, and there's lots of arguments, but there's very little empirical studies. So this is really great. We're doing it now. I'm a little confused about your classification, because you call those 13 subjects who were taking a formal course as touch typists. But those rest of the subjects who didn't take a formal course could still be using touch typing techniques, but you call them non-touch typists. And also in the findings, like, for example, you use entropy as a way of measuring their consistency. By definition, if you use less number of fingers, then each finger's entropy would be higher. But yet you're saying their speed is not necessarily slower. So there's some classifications. It's not totally clear to me.
Yeah, so about the classification, I was careful and tried to use the term trained typists more often, because this, I agree with you, this terminology is maybe a little bit confusing. So we tried to classify those that have taken a typing course versus those for which the typing strategy just emerged based on usage. So those 17s were really people that never had any instructions on how to type. This was the important thing. We also found great variations, for example, for these touch typists in how consistently they used the touch typing system. Not everybody used, for example, all 10 fingers or this fixed finger to key mapping. They varied quite a bit for some of them in how far they are away from this touch typing system. So
I'll clarify more offline, but I was just asking one thing that's more specific. There's a relatively recent study from Berkeley showing that the modern standard that every standards body endorsed, that is the 19 millimeter pitch, is actually in some sense unfounded. That is, they can be made smaller, like up to 17 millimeter. They actually do people would either do better, even for large male hands, they would either do better or the same. Given a mobile-first world, being able to make keyboard smaller seems to be a welcome message. But I don't know if your study supports that and how easy it is to actually make that change. Because the industry is not going to make changes easily unless we have very, very strong evidence.
But this is an interesting point, because finding, for example, a strategy that is as good as the touch typing system but just uses maybe 5 fingers, 2 or 3 of each hand, would maybe allow us to squeeze our hands better together and type much faster on smaller keyboards, therefore. So that's very interesting. Yeah.
I'm Jing from University of Waterloo. I have one specific question about the right hand moving more dramatically than the left hand. Do you think it's more about the text corpus provided to the participants, or because of the layout of keyboard, or it's because the right hand is the dominant hand?
So we had 3 left-handed participants, but it was the same thing for them as well. So our hypothesis was that the right hand is kind of used to switching between keyboard and mouse all the time. So therefore, it is more used to the global hand movement, and therefore it is always also used in like regular typing. That was our hypothesis. But partially it is also because you have more like the backspace and enter key, although this was not included in this analysis.
Thanks.
I'll be quick. Every year there's typing contest, and they look at the typist, and the winners are 100, 130, 135 words per minute, and obviously they're different in different countries because of slightly different keyboards. But they look at what makes those typists fast, and I don't know if this is in your data or not, but it's all those people who win are musicians. And it's not exactly because they're musicians that makes them win, but it's because the timing between each of the keys that they hit. You kind of hit at it with the preparation, but if you did an average of that timing, it's very, very, very a thin error. It's almost totally consistent between each key, and that's what makes a difference. I don't know if your data has that or not.
I have actually not looked at this part of the data, but it will be very interesting to see. Yeah, thanks.